Section 1.2 discusses the scientific method. Now, the scientific method is the way that we use in science to investigate problems and issues and just basically the universe as a whole. So we use this to investigate, to try and figure things out. Now, where we always start, unless it's some very strange and odd, more philosophical type question where everything came directly from our minds as a thought experiment, where we generally start, though, is with an observation. And so we see something or hear about something or have something explained to us, and that makes us wonder. And once we wonder why, then we move right into the next stage. And the next stage is we form some sort of idea as to what is going on that we're observing. Why does that work? How does that happen? And so we've asked ourselves those questions, and the act of coming up with an idea or a guess or a thought as to why something is happening or how something is happening, that idea of how it works is referred to as a hypothesis. Now, once we have a hypothesis, we could leave it that way, and that wouldn't really be the scientific method. That would just be us wondering how things work. In order for it to really start to become something that we can figure out or use to help explain, then we have to test it. So to test it, we come up with some sort of experiment. All right, so the experiment is some way to test whether the hypothesis is correct or incorrect. So once we figure out what we're going to use as an experiment, we can perform the experiment. It's within our ability to do. And that experiment will do one of two things. It will either tell us that, yes, this does look like what's going on. Our hypothesis seems to be correct. In fact, in terms of a confirmation of our hypothesis, the results confirm and support our idea of how things work. Or we could see that it doesn't really support what we thought was going on, and we need to come up with a different idea, a different hypothesis on how whatever we're observing is working. And this cycle can continue and continue until eventually we have enough of them that we feel more confident, and then we can use a lot of different hypotheses with a lot of different experiments and a lot of different results to come up with an overall, more general idea for how things work, and we think of that as a theory. This theory also allows us to start to predict what else could happen, even things that we haven't devised experiments for yet. So we can keep running more and more experiments based on this theory and continue to confirm it or revise it and adapt it to slightly different ideas, but we still have this overall more general big picture idea of how a lot of things work, and that's what makes a theory different than just a hypothesis, which is hypothesis being generally more of a individual, how does this specific thing work? And we'll get into laws later. So this seems really complicated, but the basic idea is you observe something, you make a guess on how it works, that's the hypothesis, you check the guess with an experiment, and then the whole cycle repeats. That's the basic idea of how the scientific method works. Now, one key aspect to the scientific method is the idea of a valid hypothesis. So when we talk about valid or invalid here in terms of the scientific method, we're talking about hypotheses. Now, valid versus invalid is not the same as correct or incorrect. So to give us kind of an idea of how this works and what I'm talking about, let's look at a problem that's kind of a classic one. when I open the door of the refrigerator, the light comes on. So my first thought might be, why does the light come on? And I might think, well, the light might come on because there's possibly a switch. That's my hypothesis, that there's a switch inside of the refrigerator. So that switch is one hypothesis. Now I can test that by seeing if I can find the switch and then pushing on it, seeing if the light goes on and off, or I can do other things which might help me to test whether there's a switch and that switch might be responsible for the light coming on when I open the door. I could have another theory. I could have this theory that small people, fairies of some sort, magical beings, are causing the light to come on every time I open the door just because they're friendly like that. So here's my other hypothesis. Magic people. So this hypothesis I can try to test. I can maybe put a camera inside the refrigerator. So when I open the door, I can maybe catch whether or not there's little people running out and turning the light on. I can put a little window in the door, try and peek in and see if I can see them. Okay. More than likely, I'm going to find out that experiments support the idea that there's a switch causing the light to go on. Okay, so supported by experiments. And I'm going to find that the magic people hypothesis, very difficult to detect. I'm going to see that this is not supported by experiments. Neither of these, however, are invalid hypotheses. They are both perfectly valid in terms of being a hypothesis. A hypothesis, in order for it to be valid, just has to be testable. You have to be able to come up with an experiment to say whether or not what you're thinking of actually works or not, actually is possible or correct or possibly incorrect. That's the only requirement. All right? So that raises the question then, what does invalid mean then? Well, what if I came up with this idea of the invisible people, or I'm sorry, not invisible people, I'm getting ahead of myself, about, fairies or sprites or something like that turning on the refrigerator light. But my experiments don't seem to show any. So I refine my hypothesis to say that, all right, well, it's invisible, undetectable fairies are turning on and off the light. All right, so now I have an issue. If my current hypothesis, is that undetectable magic people are turning the light on and off, can I test that? Well, I've just said that they're not detectable. So no experiment I could devise could prove that they're there. And no experiment that I could devise could prove that they're not there. So that means that this hypothesis isn't one I could test. The undetectable refrigerator people hypothesis, therefore, is not valid. Why? Because it's not testable. Okay. So that doesn't even mean that this isn't correct. It doesn't mean that it's not right. There exists a possibility, although I'd say it's probably pretty slim, that invisible, undetectable refrigerator people are turning that light on and off whenever I open the door. But since I can't test it, it doesn't help the scientific method, and we declare that it's invalid, meaning that it's not useful for running scientific processes and the pursuit of scientific knowledge. There's a lot of other theories that are basically invalid. I shouldn't say theory, that's a confusing way to state it, but there's other hypotheses that you wouldn't think of as being invalid because you just kind of take them as, well, They are what they are. So other invalid hypotheses. Sometimes it's just where we are in our moment of time and ability to detect things. So we might have a hypothesis that the moon is made of cheese. Well, we've been to the moon. We have telescopes that can see the moon. So we can test this as a valid hypothesis. But 1,000 years ago, or longer, that would have made this an invalid hypothesis. Because at that moment in time, it was not possible to run an experiment by visual inspection or by sending somebody there to see whether or not the moon really was made of cheese. For all they knew at that time, it could have been. And I'm probably totally butchering my ability here to determine historical scientific fact, and I apologize if I am, and you know better that they perhaps knew 1,000 years ago that the moon wasn't made of cheese, but just keep going backwards in time until you get to my point. But in any case, contextually, some hypotheses are valid or invalid based on our current ability to determine whether or not they're correct or incorrect. A more modern version of this is the universe is infinite. All right, well, we don't see an end. We can't detect an end, but that's not testable because we cannot get to an infinite edge of the universe and find whether or not that there is an edge or there isn't an edge. And we can't currently go far enough away to find an actual edge to it. So this isn't testable at the moment. We could try to test it by looking as far as we can. We could try testing it by sending out probes as far as we can. But in reality, we don't have the technological ability to determine whether or not the universe is actually infinite or not at the moment. Perhaps in the future we will, but not at the moment. All right, so invalid just means not testable. It could be a correct or incorrect hypothesis, but testable is our determination of valid versus invalid. Why that happened? So what's a law? Now a law, and I changed my pen. A law is where we are taking many hypotheses and summarizing them into an overall idea. So this is we're taking all of those experiences and all of those experiments, all the observations, so many observations, hypotheses, and experiments, and the results of those experiments. And we're going to combine those and summarize why all of those observations all fall into some general idea. So I can have the hypothesis that if I toss an apple in the air, it's going to fall on the ground. I can have a hypothesis that I can toss a feather in the air and it's going to fall to the ground. And then I can have another hypothesis that if I trip, I'm going to fall to the ground. And all of these can be summed up into an overall law that when things go up, they come back down. Okay? That's summarizing a lot of observations, a lot of hypotheses about objects fall, and so we test that this object falls, and another object falls, and another one falls. We can summarize all of that into a law of objects falling. Right? I mean, it's a little bit more to start talking about gravity, but what goes up must come down can be combined into a law. This also allows us to predict the results of future experiments. If we see that everything we toss up in the air falls back on the ground again, we don't necessarily have to wonder and feel really confused about the idea of, well, I've never thrown a cat up in the air. I wonder if the cat will come back down. Well, this law of what goes up must come down seems to apply to everything, so I can predict that it'll apply to cats as well, even though I may not have actually run that experiment yet. Okay? So what's a theory? A theory is overall just a system of observations that allow us to kind of come up with a framework to discuss a particular set of concepts. So a theory has been borne out by many, many experiments and many, many observations. A huge number of observations and experiments. Now, keep in mind that even though a theory is generally the accepted way that things work and the accepted answer and understanding for a large set of observations and experimental results, we can still be disproven. We can still have a theory be disproven just by finding one verifiable and reproducible experiment that goes contrary to what the theory says is true. Now, people use this idea that, or in common language at least, say things like, "Oh, that's just a theory." That this idea is just, what they mean by that is they're trying to say something like, "This idea that you have is just your idea. It's just what you think." Okay? That's not true. That's a hypothesis. What I think, or what I happen to believe, is, if that's the entire basis of it, it's just my belief or my thought or maybe the results of one or two experiments that I've run. That's a hypothesis, or that's a set of hypotheses that I'm working on. A theory is much stronger than that. In fact, a theory is basically as close to the truth as we can get with what we know about a situation. So a theory is actually a very strong set of connections and a very strong explanation that is very likely true, or at least as true as we can possibly make it. So to say something, just throw out, "Oh, that's just a theory," that's just, meaning that that's just what you think it is, and I can think whatever I want. Well, you can always think whatever you want, but if we're using the word theory in science, we mean that there's a lot of evidence to back that up currently. So we're full circle again. We know now a little bit more about what we mean when we say observations. We know that goes to a hypothesis, or that goes to support a law, that the lots and lots of hypotheses with lots of results may end up with a stronger belief and a better explanation that has very few holes in it that we can call a theory. Or if it's not quite that well confirmed yet, we can keep confirming and confirming and confirming and confirming until eventually we feel we know it well enough that might one day make an overall summary that lends itself to become a full theory.